Welcome to LearnSphere. In this video, you'll learn how to use the sine rule to solve non-right-angled triangle questions. Let's go into the concept of sine rule. Sine rule has a formula of A over sine A equals to B over sine B equals to C over sine C. Or it can also be arranged as sine A over A equals to sine B over B is equals to sine C over C, where small letters A, B, and C represents the length, and capital letters A, B, and C represents the corresponding angles. Let's understand the A's, B's, and C's firstly. So if we have a triangle labeled A, B, and C as angles, these are labeled as capital letters. And the corresponding sides, which are the opposite of those angles, are small letter A, small letter B, and small letter C. So we can use the formula and rearrange them based on what we are solving for, whether is it a missing side or missing angle. Let's go on to example 1, where we have the question of, in the diagram, angle ACB is equals to 45 degrees, angle CBA is equals to 70 degrees, and AC is equals to 100 meters. And we are asked to find the length of BC. So how do we identify when to use sine rule? There are two instances when we have to use sine rule. The first instance is when you know two angles and one corresponding side, or in the second instance, you know two sides and one corresponding angle. So essentially, we have to find two pairs of angle and corresponding side, where in the first pair, we know both the angle and the side, and in the second, we either know the angle or the side. So in this question, we have a known pair of angle and side, which is 70 degrees, and the corresponding side to it, which is 100 meters. And in this question, we are asked to find BC. And the corresponding angle to this side would be angle BAC. And we can find the angle for this. As we know, the sum of interior angles in a triangle adds up to 180 degrees. We can take 180 minus 70 minus 45 to give us 65 degrees as angle BAC. Now we can go on to using the sine rule. For the formula of sine rule, it's either A over sine A equals to B over sine B, or sine A over A is equals to sine B over B. So a rule of thumb regarding the formula is the unknown has to always be placed in the top left-hand side of the equation. So in this case, the unknown is a side. So therefore, this side can be labeled as small letter A, and the corresponding angle of 65 degrees would be capital letter A. For 70 degrees and 100 meters, 70 degrees will then be capital letter B, and 100 meters would be small letter b, as it is a corresponding side. So knowing this, and as we want to find BC, which is a side, we have to put small letter a as the numerator on the left-hand side. And the formula would be A over sine A equals to B over sine B. And we can substitute the values of the angles and the side to give us BC over sine 65 is equals to 100 over sine 70. Next, we can cross multiply sine 65 over to the right-hand side, which gives us BC is equals to 100 times sine 65 over sine 70, which can be evaluated to be 96.447 and can be rounded off to 96.4 meters, correct to 3 significant figures as our answer. Let's go on to example 2, where we have the question of triangle XYZ is such that XY is equals to 15.8 cm, YZ is equals to 28.4 cm, and angle YXZ is equals to 74 degrees. And we are asked to calculate angle XZY. So angle XZY is an unknown angle, which we have to find, and the corresponding side to it is 15.8. So we can label angle XZY as capital letter A. Small letter a would be 15.8 cm. And in this question, we have a set of angle and corresponding side that we know the value of, which is 74 degrees and 28.4. Therefore, 74 degrees will be capital letter B, as is an angle, and 28.4 will be small letter b, as it is the side. Next, we go on to using the sine rule formula, which is either A over sine A is equals to B over sine B, or sine A over A equals to sine B over B. So in this question, we are asked to find an angle. So we always put it in the top left-hand side of the equation. So in this case, we have to use sine A over A equal to sine B over B. Next, we can substitute the values of the angles and sides into the formula, which gives us sine angle xzy over 15.8 is equals to sine 74 over 28.4. Next, as we want to find the angle of angle xzy, we can leave sine angle xzy on the left-hand side and cross multiply 15.8 to the right-hand side, which gives us 15.8 times sine 74 over 28.4. Next, to find angle xzy, we can bring over the sine over to the right-hand side, which gives us sine inverse of 15.8 times sine 74 over 28.4. And this can be evaluated to be 31.945, which can be rounded off to 31.9 degrees, correct to 1 decimal place for an angle. Let's go on to example 3, where we have the question of triangle ABC is an isosceles triangle. Angle ABC is equals to angle ACB is equals to 26 degrees. Given that BC is 5.4 cm, calculate the length of AB. As we want to find the length of AB, we can label AB as side small letter a, and therefore capital letter A would be angle ACB of 26 degrees. Next, we can look at the diagram. We know the side of BC, and the corresponding angle to that side is angle BAC, which we can find the value of, as we know the sum of interior angles in the triangle adds up to 180 degrees. So we can take 180 minus 26 minus 26, which gives us 128 degrees as angle BAC. As now we have a known angle and side for the first pair, and for the second pair, we have to find the side. We can use sine rule in this case. So the formula for sine rule, it's either A over sine A equals to B over sine B, or sine A over A equals to sine B over B. As in this question, we want to find small letter a, we have to put it in the top left-hand side of the equation. So therefore, the formula would be A over sine A is equals to B over sine B. Then we can substitute the values of the angles and sides into the formula, which gives us AB over sine 26 is equals to 5.4 over sine 128. Next, to find for AB, we can cross multiply sine 26 over to the right hand side, which gives us AB is equals to 5.4 times sine 26 over sine 128, which can be evaluated to be 3.004 and can be rounded off to 3.00 cm, correct to 3 significant figures as our answer. Thank you for watching.